Okay. Now let's understand the meaning of electrode. So previously you saw a complete cell, okay, consisted of two electrodes. So independently, so two electrodes. So each electrode could be described. For example, if we have this particular electrode, the description is like that, neutral metal, pure metal slash cation of its own, cation. So that means it's solution. An example now is lead metal slash lead solution, so 2 plus. So envision that actually, then this is your electrode solution. So this is your half reaction. Now, the metal itself is a conductor, so it conducts electricity simultaneously. It also involved in chemical reaction. So there could be deposition or corrosion. It depends on the particular reaction. Okay, so this reaction will end up with corrosion because the lead is participate in a reaction. So now this whole deal is an electrode, your half reaction. Okay, so that is your half reaction. So when it's a half reaction, then there must be an equation to describe it. And this is from the table. The table, because this is 2 plus, and this is neutral, and therefore it involves a fixed number electron transfer. So this is what you see in the table. Okay, so the table will give you a so-called potential. So what does it mean by potential? Look at the unit. It's volt, so it's a voltage. So for E naught, okay, so this is potential, how much electron you get in a unit of volt. Now the table will give you a standard condition, so you can change based on the standard. So there's a standard condition, so-called standard condition is what we're concerned with would be the concentration. So everything is 1 molar. Okay, then of course solid has no concentration. However, this one would refer to as 1 molar. Okay? So that is your reference quantity for potential. Now, what is written here is reduction. So the table gives you is the reading for reduction potential, whatever that volt is. Now, if somehow you arrange such that this is your oxidation half, not your reduction half, because of combination properly. Okay? So if you need this to be oxidation, then the reaction is switched the other way around. So in terms of oxidation potential now, it's just the switch of the reduction potential. So because you switch that, so you need to add a minus sign in front. Okay?
Wait.
Yeah.
What is the E and then parentheses B and T, or what is it? No. Above it. On top of that? That one.
Volt times.
Oh, volts, then what? Oh, volt. Oh, that's what it is? Oh. Thanks.
You're welcome, Mr. Yaska. Oh, well, I pay attention to your name one day. I said, seems to be familiar. Oh, Lady Gaga. I said, I've seen this name before, but somewhere, the spelling is a little different. Yeah, that was fun. Okay, then electrodes. as long as you have a conductor, then it will function for conducting electrons. And not all chemical reactions you want your conductor to participate in reaction. You know, you don't want electroplating and you don't want corrosion of your conductor, and therefore you use some inert wire, although it's expensive, you know, platinum. So there's an example for platinum that you have the cations coupled in solution. So example will be like this. Platinum is solid, so you have the couple, redox couple in solution to initiate the electron transfer. So you must need to have both, more or less, okay, because this guy doesn't participate in reaction. Previously, your lead will participate, right? Okay, so you have the two, more or less, concentration. So this is your electrode actually, and also your half reaction. So now you write the half reaction to describe it. So in case your arrangement calls for reduction, then this is your reduction equation. In case for oxidation, you just switch the other way, okay? So this is your oxidation. So the E without a knot is just, you know, whatever the concentration, so experimental concentration. Okay.
I already have a picture.
Okay, now when you try to combine the two chemicals properly, so what it means is you want to see, once you combine two chemicals, will there be chemical reaction? Not any two chemicals combined will give you chemical reaction, right? Okay, so let's say you have a chemical A, okay, you know is in the reduced form. Chemical B, you know is in the oxidized form. Okay, so you mix the two. If you get a reaction to occur, then this is what will happen, right? So one is oxidized, the other one is reduced, so this is a reaction. So even though they are the same substance, actually for chemicals, they are not the same anymore because the oxidation numbers are different. Okay, then this is the key thing. To realize a reaction occur, then the E overall must be positive, That it indicates spontaneous reaction. So we will stress this point later on, you know, to let you know how to determine that is positive. So combining the EOX and ERAD becomes redox reaction. And then the combination, you will end up with an E overall is positive, cannot be negative. Okay, now looking at the chemical by itself, because now you have a complete reaction, you know this reaction goes. Then this chemical now, okay, is called the reducing agent. Why? Because itself, after reaction, is oxidized. On the other hand, this guy is called oxidizing agent because after chemical reaction itself is reduced. So these are just terminology, okay? Notice agent, that means that's what they act on during an reaction. Okay, so more detail.